Being recorded. Welcome everyone. Good to have you. We're going to talk about percentages, the second skill in problem solving. We'll try to cover the main ideas and then we'll try to start working on one variable data skill, dealing with one variable data, reading graphs, and so on and so forth. Right now we're doing one variable data exercises on going to spend maybe 6 more minutes and then do a couple exercises before we so I'll give you as usual 60 seconds to crack this problem. This is a really good exercise. As usual, I'll start writing down some stuff. We have some data, some numbers. The first number, second number, so on and so forth is the 27th number. Now the mean of these numbers is the sum of the numbers divided by their count, which is precisely 27, is 33. And the median, which is the number that's right in the middle, you have 27 numbers, there's probably 13 before and 13 after. So it's just saying that the 14, there are 13 before and 13 after, is also equal to 33. So the median is the number that's exactly in the middle. I'll also color this one red. The mean is just the average. Never seen this before. Okay, so I'm writing down some stuff. Let me go on. A new data set is created by adding 7 to each number. Each number that is greater than the median. Subtracting 7 from each number in the original data set that is less than the median. So I have the same 27 digits, but here's what I do. I add 7 for each number that's greater than the median. So the median is in the middle, it's 14. E14. Now, if you're greater than the median, I add 7. So I have D15 plus 7, D16 plus 7, so on and so forth, till D27 plus 7. And if you're less than the median, then you take away 7. D13 minus 7. Now, the minus 7 is not in the index, it's just an index. But I take away 7 from the number D13, just to make this clear. I go back and back and back all the way to first digit in my set, minus 7. Now, which of these changes does not have the same value? It's a good question to ask. Is it clear now, at least, the formulation of the question, if you still have not figured out what the solution is? So, for example, what happens if we just sum up all of these values? We get, let's say, the same sum here. We do, because it's just you added this many 7s and then you took them away, then it's fine. Fine. So the sum doesn't change. And the thing is, the number of digits did not change either. So we're still dividing by 27. Still have 27 digits. And so the mean has not changed either. So it's not the mean, not the sum of numbers, and it's not the median, because, well, the median is the number that's right in the middle, right? And the only way you would change the median if you add a value, let's say, to the left or to the right, because then it's no longer in the middle. But if I still have the same amount of digits, then I have exactly the same median. Then what is going to change is something called the standard deviation. And what is precisely the standard deviation? Roughly, I'll say that it is the average distance from the mean. I mean, this is not precise, it is precise if you define what distance is. I don't want to get into this, but what I want to say is that our first data set had values which were relatively close to each other, D1, D2, D3, and so forth. But if you do this, if you take away 7 from here and you add 7 from there, then the range of your set is larger, and the distances between at least these numbers and these numbers gets larger. So there's a larger deviation from the mean, if that makes sense. Mathematically, there's a way to precisely compute this deviation from the mean, but here it is clear that the new numbers that we have are dispersed more than the original set of numbers. So I hope that's a good introduction to what the standard deviation is. I'm not sure if you want to do another problem. Maybe I'll just give you 2 minutes to do it, and then I'll give out the solution without saying, without giving any explanations, because then we'll be out of time. So I cannot say anything outside of our lecture time. Well, the answer is just going to be 0. I don't know if you want to listen to an explanation or not, but roughly speaking, I'll just say that this data is symmetrically distributed, 3, 2, 1. And so if you have this type of symmetry, then the median value is equal to your average. Because everything is symmetrically distributed. Because here's the thing, you might fall into the trap of thinking that these are values that you should compute, but in fact, these are frequencies. So if I say A is equal to 1, then I have one value of 1, I have two values of 2, three values of 3, two values of 2, and one value of 1. So since the data is ordered in this very specific way, this is for A is equal to 1. A is equal to 2, I just get 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, 2, 2, 2, 2, 1. So clearly the median is always going to be this, right? It's always going to be 3. It's always the value in the middle. You can always spot it, like spot it from here, or it will be the average of these two, which is still 3, so on and so forth. If you want to look at the average and you want to check that this is indeed going to be correct, then you say, okay, I have how many values? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 values. So the problem is that if you write 9a over 5, it's incorrect. You need to consider all the values. So you write 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3. And then you divide by 9. So actually, divide by the frequency. So this appears 8 times, this appears 8 times, and so on and so forth. Well, actually, this is going to be but the idea is still the same. You need to stop talking. You need to finish it. But the total number of data points is 9A. In the case of A is equal to 1, we have 9 points. And then I do this. Why is this going to give me 3? Well, if you compute it, it will give you 3. But why is it going to give me 3 when A is not equal to 1? Because the number of ones will just double. Here I had 1 1 and 1 5 and 2 4s and 3 3s and 2 2s. But if I double this, it doesn't matter. I'll just double this whole thing, but I'll also double the amount of numbers that I'm adding. Or I'll just remove 2 and I'll put A. It's the same thing. So the A doesn't really matter. If you divide this by that, you get 3. And if you make the good observation about the median and be very careful to notice that this is frequency and not value, then you should be able to crack this problem. Thank you very much for being here with me today. It's been an absolute pleasure. And I'll be here if you have questions.
Thank you.
عندك أسئلة ولا نقفل؟
لا صراحة بس ده ما فهمتوش فروح اذاكره بقى.
فاهم بس الاكسرسايزز ولو واقف معاك حاجة قول لي.
يعني ما فهمتش الشرح يعني نفسه ان هو ما فهمتش الطريقة.
نقفل يا جماعة؟ حاجة ده